Hello, my dear students. A very welcome to our channel. I hope everyone is okay. Everyone is well. So by this video, we will start a series of class 9, 10, 11, and 12 computer science concept-based question. So today's video is all about class 9, chapter number 7, coding and it's important. Okay. So everyone knows that how coding is important in our digital world. And it's vastly very much important in every software, every website, everything which is as a digital needs coding. And everyone knows that all most of the machineries are understand only binary language. So before starting a code, we must know how to construct the instruction for the computer to understand first by the human being. So there is a pathway where everyone knows, everyone have to learn how to construct the smoothest path for that particular operation. So in this class, we will focus on how to create flowchart algorithm and some of the problem solving methods. Okay, first in this chapter, the key importance of the topic is your problem. What is a problem actually? Okay, problem. What is a problem? So basically, problem is a task. Okay, a your a issue or a target. Okay, so whenever there is a problem or there is a question, and we should have a particular way of solving it. Like this is called a problem solving. The method through which we solve a problem. Problem solving. Okay, so there are different kinds of problem. Like we can categorize in two types. One is a normal problem which doesn't have which has a lots of confusion regarding the problem, and one is well defined problem. Okay, so basically a well defined problem is a problem through which we can understand a question better and more clearly. Okay, so a well defined problem. Okay, so a well defined problem has some values. Okay, some points, key points. Okay, so in the using this particular points, we can solve any problem. To solve a problem, there are 5 steps. There are 5 steps. Okay, so step number 1, that first identify. First identify the problem. Second, analyze. Analyze. First, identify. Second, analyze the problem. And third, implement. Okay, so sorry. First, in identify the problem. Second, analyze. Then, for third option, it is developed. Developed what? Developed a solution. Okay, so first you identify the problem. Second, you analyze it. What is the problem? Then third, you developed a solution. Okay, so after developing the solution, what you have to do is that you have to implement. Okay, so implement the solution. Okay, so last step is to evaluate. Okay, evaluate the solution. So these are the main 5 steps, which is first one, to solve a problem you need to understand these five steps. First, identify the problem. Second, analyze the problem. Third, develop the solution for the problem. Fourth, implement the solution. Then lastly, which is evaluate the solution. Okay, so we'll move on to the next one. While solving a problem, there are some strategies. So first one is to background knowledge. Background knowledge. Okay, so if I ask you a question and if you don't know about the root of the questions or a root of the concept of that question, then you will not able to solve it. So for that you need to have at least basic knowledge of the question. Like if I ask you to how to cut a tree, you should know how to axe it. First you need to how to hold a axe or something, I know, like that. So second one is use guesses. Okay, use guess. Okay, use guess. So use guess is like that, while solving a problem you just give some ideas pop up in your head, and you are going with the instinct. So that one. Third option is draw a picture. Okay, draw a picture. Okay, so path, like first I will do this one, second I will do this one, third I will do this one, fourth I will do this one. So like that, it's kind of a roadmap for the problem. So these are three strategies we can follow. Then while solving problem, there are another most key important is there is 5 W's. What is a 5 W? So 5 W's are basically like what, when, why, where, and who. Okay, so these 5 W's are applied while solving a problem. First one, what. So what is the problem? Second one, the time period, or maybe it's related to the time frame. Next thing, why you should solve the problem. What is the cause? What is the root of the problem? Then where you have to solve, what you have to use. Okay, and for whom you are solving that problem. Okay, okay, so these are the some related topics regarding the problem solving method while in the flowchart category. Okay, so next one we will start with the main topic, which is our flowchart. What is a flowchart actually? So basically flowchart is a graphical representation or diagrammal representation of a process, or before a process where you start solving a problem. Okay, so we can go for like this, a particular small diagram, which is, suppose this is your problem. This is your problem. And then here is flowchart. Okay, then there is a algorithm. Okay, then there is a programming. So first what we have is that if we had a problem, then we go for a flowchart, then we go for an algorithm, then we make the program. Okay, for example, making a website. First of all, what we do is that our problem is that we have to make a website. Second thing, these flow chart and algorithm are interchangeable. Like we can make an algorithm first, then make a flow chart, or we can make a flow chart, then after that we can make an algorithm. So our task is here is that making a website. So we have to make a website. For that, our problem is to make a website. So we will work on the solution is that we will need an algorithm or a flow chart, a roadmap, what we will do, what we will use, the design, the theme, the text format, okay, pictures and all these things. Okay, then after that, at the last end, we will go for the programming. Okay, why is it helped? Because you see, you have a clear path where you are going. Because creating a roadmap is easier to detect problems as well as smooth workflow. Okay, in that case, making an software also you can take. Okay, if you are making a software, so for that also this particular way of working is efficient. Okay, so in flowchart there are particular diagrams. Okay, first of all, you can consider flowcharts are like this. Like you have input, then process, then output. Okay, first we have an input, then we will go for the process, then it will deliver us a result. So in this process there are some certain diagrams which we use in the flowchart. Okay, so first of all, is your a oval shaped diagram. Okay, this is connected. Okay. This is called start or end. Some people might say stop also, so that is also okay. So it is stop. This is a diagram where when you start a flowchart, this is used, this is has been used, and when you end a program or end a flowchart, this particular shape is used. This is called start and end. Start or end. Next thing is it's a parallelogram like this. Okay. It is called an input slash output. Okay, everyone knows input, everyone knows output. What is the input? When you give an instruction to the computer, that is the input. What is the output? When the computer shows you the result of your instruction is called the output. So when we will use flowchart, some inputs might have to give, or some outputs we have to show, the computer has to show us. So in that case we use this particular shape. It's a parallelogram. Third number, it's this one, this rectangle shape. Okay, so this is called a process. Okay, so this is input output, this is called process. So when you use, say if there are any kind of processing things, like for example we are doing a plus b, like a plus b, suppose a minus b, anything which is process, we are doing a particular process. So in that case we use this particular diagram. Okay, and fourth diagram is very important, which is your this one. Okay, it's a decision diagram. Okay, it's a decision. It's a decision diagram. So here basically decisions occurs. Like for example, you say conditions. Here two things are there, right? It says yes and no, or true and false. Okay. So in computer language or in computer science, I think as a class 9 students, you know that there is which is called true and which is called false. Okay. Okay, two things are there, true and false, or yes and no. Okay, or zeros and ones. So in this particular diagram helps you to find these true and false statements. Okay, evaluate these true and false statements. Next, fifth option is our is a connector, flow line connector. Okay, it's a flow line connector. Okay, it's a flow line connector. Okay, so when there are several connections are there in the flow chart, this circular diagram used to connect those lines. Okay, so if we say flow line connector, then what is a flow line actually? So basically when the data flows in a certain direction, it uses some lines. These are called flow line. They carry data. Okay, so seventh and last is it's not that much of important, but when you have to connect outside of a page, like we use no PT or something like that, no, so it's used like outside of page connector, like this one, off page connector. Okay, so this is an on page connector and this is an off page connector. Okay, so these are the main diagrams which are very important to understand and as well as to remember, because in the flowchart diagrams, while making flowchart diagrams, they are very efficient. If you remember them, then you will be very, I think, efficient. Okay, so let's start with an example, I guess. Okay, first example, let's take number one. Let's start with a basic example that we have to do a plus b. Everyone knows what is how to do a plus b. Okay, so a plus b. I hope everyone knows about variables and these things. Okay, if you don't know, then I'll try to explain it on the way. Okay, so the rule is we write start first as start. Okay, so we'll start. What happened? Okay, start and this owl diagram. Okay, so next after that there is a flow line, and it will come to an input output box, which was our parallelogram. So let's make an input. So here we need to let the computer understand that A is a variable and B is a variable. So what we will do, we will input A and B. Okay, so after that there is a supposed to be a process. Where is the process? Is our addition. Okay, so the process box will come, which is our rectangular shape. Okay, don't mind the curves. Okay, here it will be, suppose we take a additional variable which will hold the values of a plus b. Okay, which hold the results of a plus b. So we'll get sum equal a plus b. Okay, here one thing you remember, that in computer equal doesn't mean that something is like this side is equal to this side. Okay, it means that we are assigning a value, like for example x is equal to 1. I'm not saying x is equal to 1, I'm saying that x is assigned with 1. Means whenever I have to use the x, I can whenever I have to use the use any values against this particular variable, I can use. So simply you can take there, here there is a box. Okay, in that box there is a x variable. Is that it's like a big box, and there is a x variable where I have assigned a value. I put a value for x as a 1. Okay, so we have earlier also in maths, and we have taken that, you know, a is equal to 1, b is equal to 2, something like that. So they are not equal, they are just assigned with this particular variable. Okay, next. So one more thing, that here equal means equal means something is equal to something. Okay, so next here, so we have to print this one. So we'll write print sum. Okay, clear? Okay, now here it's an output. So for output, the parallelogram diagram. Okay, let's just connect this, and so after that we don't have anything, so we'll write stop or end, and end of the diagram. Clear? Okay, like this. So this is a very basic one. Okay, so here two things are attached. When there was a question for flowchart, there might be asking for algorithm also. So we will learn about how do we write algorithm in proper way. So first of all, we will learn how to draw a flowchart first. Okay, so these are flow lines. These are flow lines. Okay, and everyone knows these input output box. This is a processing box. Okay, this is a start and stop box. Right, sorry, start and stop. Okay. So here also, first you start with this start box. Okay, the oval shape, and then input, then process, then output, then stop it. Okay, understood? Okay. Okay, so let's take an example. Again, one example. Let's say if we can perform area. Suppose we have to find the area of a suppose rectangle. Okay, so everyone knows what is the area of a rectangle. It is L into B. The small looking like I. Okay, L into B. So area equal to L into B. So let's, here our variable changes to L, changes to B. So let's start with it. Start first, input L and B. Okay, second, same. Here will be a process which is area equal to L into B. See, one see here, one thing is, in computer the multiplication symbol is star, okay, and the division symbol is slash, this one, okay. So, and this is not a percentage symbol, this is called modulus, okay. So this is our process. So we'll inside the processing box, then output will print area, okay, we'll print area and stop, done. Okay, so this is a quite easy process, okay. So everything clear? Next, let's say we have a little bit difficult question, okay. Now what we have to do is that we have to find a number is even or odd. So there will be a number which will be given by the user, and you have to find that that number is a even or odd by a flowchart, okay. It's a very interesting concept. So the basic concept here is that the number, whatever the number will be, suppose n number, okay, number, anything, any number. So if the number is divided by 2 and leaves a remainder 0, that means the number is even. So everybody knows, okay, this one. And if it leaves a remainder of 1, that means it's an odd. So we have to use the decision one, so where there will be 2 outcomes, okay. So let's start, okay, okay. Next, input. Here we will need to input, give a certain, so here only a number, it says not a one number, so we'll write input, let's say n, okay. After that there will be a decision. See, earlier I told you about the modulus symbol, so here we will use the modulus, because in division we get the quotient as our answer. So we don't want the quotient as our answer, so we want the remainder as our conditional statement. So here we will write is, okay, n mod 2 equal 0. Okay, I told you earlier also, equal means something is equal in computer language, and only single equal means something is assigned to a variable, okay. So like this, here two outcomes will be there, one which will be true or yes, and one which will be a no, okay. So here no. Let's say if the number, okay, if the number is divided by 2 and gets a 0, then that is will get, okay, and output will be, so we'll print even. So that number is a even number. And if it doesn't get divided by, it gets divided by 2 but not appears to be as remainder as a 0, but instead of it, it's appeared as a 1, then it will be an odd number, okay. So like this, then connect these two, okay. Let's connect this two with the end one. So we'll stop, okay, done. Now here we look, so modulus, what it does, that when you use a modulus, it gives you the remainder as a answer, okay. Sorry, so if I take suppose here I write output, suppose here n is equal to, I take 10. So here what will happen, that 10 will be divided by 2. Yes, we know 10 is divided by 2, but here the answer is not the quotient, will be the remainder. So by this we can know that the remainder is 0, and it means the number is divisible by 2, and the number is divisible by 2 means it's an even number. If it doesn't get divided by your 2, like for example n, if I take 9, suppose. So 9 4s are, and 2 4s are 8 and 1. So 1 is the remainder. So if I take n is equal to 10, then I will go this line and I will get the result of this one. And if I don't suppose if I don't take n is equal to 9, 10 as I take n is equal to 9, so I will go to this particular condition and it doesn't satisfy, so I will go for this path, no part, where I will get the odd statement. Okay, here. Okay, next question number 4. Where is it? Right. Yeah, so now the question is that suppose there is 3 numbers, suppose a, b, c. So now you have to find out, okay, which one of them is the largest. Okay, largest number, which one of them is the largest number. So there are different ways where you can perform this particular task. So the basic thing is we will check a, b, c. Okay, first check a, then check b, then check c. Okay, how we do it? We compare them. First we compare a to b, then we will compare b to c, and at last we will compare a to c. Okay, so in that way we can be certain that which among the numbers is the greatest. So as usual we will start with that. Okay, next, first of all what we will do is that we will input these 3 variables. Okay, input a, b and c. Okay, so next, okay, first condition, let's we take that a greater than b. Okay, we have taken that a condition where we have assumed that a is greater than b, any condition. Okay, there will be 2 ways, where one will be yes, means it is correct, and one will be which is no, which is incorrect. Okay, so in the yes section we can follow the a and we can write another condition, which is a, we are comparing a with c, is a is greater than c. Okay, so if still this is yes, or still this is correct, then we will move to the final conclusion of ours, which is print a. Okay, so we have compared with all 3 of them and we found that a is the greatest. Okay, if this one doesn't happen, and if a is not greater than c, okay, if a is less than c, then we will move to this no section. Okay, so here this condition doesn't satisfy, so here we will go for an alternate route, which is print, okay, c. Let's see, we'll hold on to this one for now. Okay, next one, here, if a is not, at the first only, if a is not greater than b, and we found that b is greater than a, so in that case there are one condition we can put here. This is a, sorry, is b greater than c. Okay, we are checking that b is greater than c or not. Okay, if there will be 2 conditions where one will be yes, b is greater, and one will be no, yes, b is not greater. So if it is greater than c, that means we have got our answer, which is print b. Okay, so the greater number will be, or the larger number will be b. Okay, and if it isn't, then we can say that yeah, we come to the last conclusion which we had earlier, which is our c is greater. Okay, so I'll try to explain it with an example where, okay, so connect these both and the end, or we can write stop here. Okay, like this. Okay, let's see with an example. Suppose we have taken for one example 6, 4 and 2. Suppose we have assigned a as a 6, b as 4 and c as 2. So if we compare here, a is 6, b is 2, sorry, b is 4. So clearly we can see here that a is bigger, so we will move to this part. Here a is 6, c is 2. So compare, if 6 and 2, clearly a is bigger, so we'll move directly to the yes section and we will print directly the A. So the A is the largest. Now if we compare this one, second condition, which is if 6, 7 and 2. So if we assign here 6 and B is our 7. Now we cannot go this side because this is wrong. See, A is not greater than B. A is 6, B is 7. So 7 is greater. So we will go for this part, which is no. So here B is 7 and C is 2. So now we can clearly see that B is not greater than C. Okay, so B is not greater than B is greater than C. So if it is greater than C, then it will go for yes part. So we can know that B is greater. Okay, so it will meet after end. Now if it occurs in a different way, like for example 6, 7 and 8. Suppose A value is 6, B value is 7. Okay, so clearly 7 is bigger, so we'll go this way. But here B is 7 but C is 8. So clearly 8 is bigger. So we will not go for the yes part, we will go for the no. So the condition is not true. So it will indirectly will meet with the C section. Okay, this part C, print C. Okay, so like this. Okay, clear? Okay, students. So I hope you like the class, and for the next videos we will uploading soon. I hope you will like, share and follow us for more videos. Stay tuned and